Okay, so in this video we'll be looking at congruence, and in particular we'll be exploring congruent triangles. So we say two objects are congruent if they are exactly the same in every way. Even if one of them has been turned or something, they're the same size and the same shape. And this is a description that can apply to any two objects that are the same, not just triangles. But we'll be looking at congruent triangles because they're particularly useful in exploring other shapes, like parallelograms and their properties, which we might do later. So pretend we're given two triangles and our job is to decide if they're congruent or not. Well, a triangle has 6 measurements. We have 3 side lengths to check and compare here. Maybe we need to make sure all matching sides are the same length. But we also have 3 angles here. Maybe we need to make sure all matching angles are also the same size. But it turns out we don't need to check all 6 measurements, and the way we'll argue this is by pretending we're physically building triangles with certain given measurements. And we'll illustrate by giving an example of something that doesn't work, which is only checking 2 pairs of equal sides. Remember, the question is this enough to guarantee that 2 triangles are completely the same in every way? And why doesn't this work? Well, let's model this situation with 2 steel beams joined together like this, so 2 side lengths that are fixed and can't change. Even though the side lengths can't change, we are still free to swing the sides back and forth like this. And what that means is it's possible to create 2 different triangles that have those same 2 side lengths. We just need to swing them different amounts. And the resulting triangles will be different. So the answer to whether it's good enough to check 2 pairs of equal sides is no. Alright, given 2 pairs of equal matching sides, the 2 triangles might be congruent, but we don't have enough to guarantee that they are definitely congruent yet. What if we upgrade to 3 pairs of equal sides, so 3 fixed steel beams like this? Well, hopefully you can imagine that this triangular structure now can't move, it's stuck. And because it's stuck, any other triangle we could possibly make with those same 3 steel beams must be exactly the same, must be congruent to the first triangle. There's no way of changing it in any meaningful way. You can do things like turn it or flip it, but it's still essentially the same triangle with the same 3 side lengths and the same 3 angles because it's stuck exactly in that shape. And so that means that having 3 pairs of equal matching sides is good enough to guarantee that 2 triangles are congruent, and we call this test SSS for side, side, side. You check 3 equal matching pairs of sides. For our second test, let's try to salvage the 2-side situation in a different way. What we're going to do instead is nail down this angle here so the 2 sides can't swing anymore. And now hopefully you're convinced that this picture is stuck. Any other triangle we make with those 2 side lengths and that angle locked must be the same because the picture is unable to change into a different triangle. It's stuck in that shape. And so what we have here is 2 pairs of matching sides and a pair of matching angles. But could it be any angle? Actually, no. Pretend the angle we locked was down here instead. Then actually on the triangle on the right, for example, the steel beam on the left is actually free to swing across to here. We haven't changed the lengths of the beams, the angle is actually still good, but the blue edge has shortened a lot. And so that puts a restriction on when this test works. It's only when the matching angle is between the matching sides. And because of that, we write SAS for side angle side with the matching angle in between the 2 matching sides. Hopefully you're getting the idea, so we'll run through the last 2 tests a little quicker, just showing that with certain given pieces of information, the picture is stuck to guarantee the test works. So one of them does this. We lock 1 side and 2 angles. So now imagine, laser beams shooting from those 2 corners. The angles being locked means the direction of those laser beams is fixed, it can't move. So you see that the third corner must go here. And the picture is once again stuck. We call this test AAS for angle, angle, side. And the last one has this. It looks a bit weird, but that's a right angle there. And if you look carefully, it should remind you of SAS, because we're fixing two side lengths and an angle. But the difference is that the angle isn't between the two sides, which we insisted on before. The idea is that if the angle is a right angle, it doesn't need to be between the two sides anymore. Well, why is it different for a right angle? Well, physically, because there's no way of swinging this picture into a different triangle. But to convince you of that, see this missing side length down here? Given the other two fixed lengths and the fact that there's a right angle there, we can actually use Pythagoras to calculate this last length. So really, it's fixed as well, and the whole triangle is indeed stuck. And we call this one RHS for right angle, hypotenuse, side. It's pretty much SAS, where if the angle is a right angle, we get to have the angle not between the two sides because Pythagoras comes in to save the day. So to summarize, we have 4 tests that guarantee that two triangles are congruent. We have SSS, where we check that all matching sides are equal in length. And the benefit of this, which we'll see later, is that if we can guarantee that all 3 pairs of matching sides are equal, then we obtain for free that all matching angles are equal as well. We have SAS, where we only need to check that 2 pairs of matching sides are equal if we also check that the angles in between those 2 sides are equal. Then we get the third side and the other 2 angles for free. We have AAS, where we only check 1 pair of equal matching sides, but then we need 2 pairs of equal matching angles. And again, we get the other 2 sides and the other angle for free. And finally, we have RHS, where we have a right angle, equal hypotenuse lengths, and another pair of equal matching sides, and we get the other side and the 2 angles for free. So those are the ways we can tell if 2 triangles are congruent. We'll deal with some examples and stuff in the next couple of videos. Thanks for watching.